Problem number 5. A police inspector in a car is chasing a pickpocket on a straight road. The car is going at its maximum speed V, assume uniform. The pickpocket rides on the motorcycle of a waiting friend when the car is at a distance d away and the motorcycle starts with a constant acceleration a, so that the pickpocket will be caught if V is greater than or equal to root of 280. So see, first let us, we will assume both the pickpocket motorcycle and the police inspector car as particle model. No size is given, correct? So suppose this is car and this is a motorcycle, I am denoting by M, and this is by C. Okay, the car is moving with a constant velocity. It is given that assume the velocity to be constant V. Okay, and this is the maximum speed, and the pickpocket is going to ride on the motorcycle of a waiting friend when the car is at a distance d. Okay, when the car is at a distance d, okay, so there is the motorcycle and the motorcycle starts with a constant acceleration a. So initially the motorcycle was at rest, and when the car was at a distance of d, the police car was chasing the pickpocket, and when the car was at a distance d, the pickpocket just went to the motorcycle of his friend, who the friend was waiting with the motorcycle, and they went away with an acceleration of how much? A. Okay, so this is the scenario. So say, first of all, we have to take our t0, that is where we are taking the reference time. So see, we are an observer on the ground. Okay, suppose I am observing from the ground, and when I see this instant, that the pickpocket is riding the motorcycle, which is static and starting with an acceleration a, and at this instant the car was behind a distance d, I started my stopwatch. Okay, so this instant I am taking as t is equal to 0. Got it? And here I am taking as the origin. Here I am taking as the origin, and there I am taking as the positive x-axis. Got it? Now we have to prove also that the pickpocket will be caught if V has a certain minimum value, that is V must be greater than equal to root of 280. That is a common sense, you know, there must be some certain critical minimum value of the car, otherwise, you know, the pickpocket will escape with the motorcycle. So we have to prove that the police car must have a minimum speed which will be given by root 280. So we know whenever the particles meet, collide, caught, they have the same position. Okay, so suppose we are taking a model in which the pickpocket is caught at a time t. So at a time t, the motorcycle and the pickpocket will have the same position, yes or no? They will have same position. Okay, I don't know whether he will be caught or not. We are assuming that let him be caught at time t, and we will see what will be the consequence. Let the pickpocket be caught at time t. It means when the pickpocket will be caught, your stopwatch would be indicating how much time? A time t, correct? Your stopwatch would be indicating a time t. Now since this was the instant when the stopwatch indicating a time 0, so from this instant, this I am taking as the initial instant, this I am taking as the final instant. So from I to F, can I say both the car and the pickpocket has the same time of travel, HE? Clear? Because you know that was the instant t0. So from this instant to this instant the time elapsed is t. So in this interval the car must have travelled a distance, a time t, and the pickpocket must also have travelled a time t. So both have the same time interval, and when they have the same time interval, you can also apply the relative equation. Okay, whenever the particles meet, we know when we apply the relative equation, so x to 1, that is the final position of 2 with respect to 1. x naught initial position, x naught means initial position of 2 with respect to 1 plus u21 delta t plus half a21 delta t square. You can also find, both the positions separately and then equate them. One way is find the position of the pickpocket after a time t, find the position of the police car after a time t and equate them. That is one way. Another way is that since they have the same time of travel, delta t is same, so we can also apply the relative equation. X21 is what? The final relative position. Final relative position is, that is the position of 2 with respect to 1. This is the final relative position. X021 is what? The initial relative position. U21 is what? The relative velocity, initial relative velocity. And A21 is what? A2 minus A1, the relative acceleration. So we can apply this equation in this case. And when the particles meet, we know when particles meet, they have the same position. So their relative position becomes 0. So what is the advantage of applying the relative equation? You need not to apply the position time equation twice. As I told you, there is one approach also. Apply the position time equation for pickpocket, for car, find their positions at a time t, then equate their positions, the time will come. But if we want to reduce the working and the time interval is same, so we can also apply this equation, correct? Let's see carefully. We have to write all these quantities carefully. So I'm taking this side as the positive x-axis. So let us see the initial position. So what is the initial position of car? So the car is at origin. What is the initial position of the motorcyclist? So this is plus t. So therefore, the initial position of motorcyclist with respect to car will be the initial position of motorcyclist, that is a relative equation, initial position of the car. Whenever you write the relative equation, it is 2 minus x21. So we're applying the same approach here. So the initial position of motorcyclist with respect to car will be what? D minus 0, that is d. I am doing a very detailed approach. Otherwise, you can write all this thing in one step mentally. You can see the car is at a distance d. Sorry, the motorcycle is at a distance d from the car on the positive side. So the initial position of motorcycle with respect to car is plus t. Okay. Now let's see the initial velocity. The initial velocity of car is v plus v. Initial velocity of motorcyclist is 0. So therefore, initial velocity of motorcyclist with respect to car will be velocity of motorcyclist minus velocity of car. So this will be 0 minus v. So that is minus v. Okay. Now acceleration of the motorcyclist plus a. The acceleration of car is 0. So acceleration of motorcyclist with car is a of motorcyclist minus a of car. So it will be plus a. Got it? So now you can find the relative position at any time. So the position of the motorcyclist with respect to car is the initial position of motorcyclist with respect to car plus the initial velocity of motorcyclist with respect to car into delta t plus half of acceleration of motorcyclist with respect to car delta t square. Now simply put the values. So I'll get this thing as what? Plus t. This is coming to be minus v, delta t is t, and this comes to be half a t square. Okay, so this is coming to be the relative position. XMC means the position of the motorcyclist with respect to car. Now when the motorcyclist or pickpocket is caught, when he is caught, so as we have seen, when the two particles meet, collide, caught, they have the same position. So their relative position becomes 0 because they are the same position, so there is no relative separation. Okay. So if you are finding the time for being caught, put this thing as 0. So you'll get d minus vt plus half at square will be 0. So you'll get 2d minus 2vt plus at square will be 0. So you'll get at square minus 2vt, we are writing in the standard quadratic form, 2d is equal to 0. So this will be the quadratic equation which will give you when he will be caught. Now, see, since t is equal to 0 is taken as the initial instant when the car was d distance away. So, for being caught, there must be two conditions for this equation. The root must be, number one, real, then only the event will take place. If some event is taking place, you are assuming that event is taking place. We actually don't know whether the event is taking place or not. But you are assuming that the event is taking place at a time t. And t is coming to be the root of some quadratic equation. So if both the roots are imaginary, the event will never happen. So for the event to take place, the root must be real, number one. Number two, this is necessary condition, not sufficient. Since t0 has already occurred, so number two, time flows forward, so t must be positive, number two. Okay, so suppose if t is coming to be real, but it is coming to be negative, then also that event will not occur after t0, correct? So if t0 has occurred and some event is occurring at a time t, and t is the root of the equation of some quadratic equation, so there must be two conditions, the root must be real and the root must be positive. Okay, now let's see here. If you compare it with the standard quadratic form, at square plus bt plus c is equal to 0. So I'm getting the value of a as small a, I'm getting the value of b as what? Minus 2v, I'm getting the value of c as what? 2d. So I will get t is what? Minus b plus minus b square minus 4ac by twice of a. So I'll get minus of minus 2v plus minus 4v square, that is b square, minus 4ac, that is minus 4 to 8 ad under root by twice of a. So this is coming to be your value of t. Now let us put the first condition for real t. The discriminant, that is what is inside the radical, we all know that is the discriminant, must be greater than or equal to 0. So for this 4v square minus 8ad must be greater than or equal to 0. So 4v square must be greater than 8ad, so you will get 2. So v must be greater than 2ad. So first condition is that v must be greater than or equal to root 2ad, number one. Number two, you have to convince that the value of t will indeed come to be positive. Now see, it's 4v square, correct? And the root of 4v square, will be 2v. Now a is a positive quantity, that is the acceleration, magnitude of acceleration, and d is a positive quantity. So here this whole thing is positive. So something positive is being subtracted from 4v square. So surely you can say 4v square minus 8ad will be less than 4v square. Surely, because this thing is positive, so something is getting subtracted from 4v square, so this whole quantity will be less than 4v square. Now if you are taking the root, you will get 4v square minus 8ad root will be less than 2v. Okay, so this quantity which is inside the radical is less than 2v. So now let us analyze the nature of the roots. So say I am taking here the plus sign. So the first time where he can be caught is 2v plus 4v square minus 8ad under root divided by 2. Now there is no scope for this root to be negative because here it is a plus sign. So surely this root is positive. So at this time the motorcyclist and car would be meeting for sure, correct? Now let's see the nature of the second root. When taking the negative sign, so it will come to be 4v square minus 8ad by 2a. Now what do you think? Will this root be positive or negative? So we have done the mathematical analysis. This whole thing is coming to be less than 2v. So when you are saying this whole thing is coming to be less than 2v and you are subtracting this thing from 2v, so of course this thing will be positive. So this root will also come to be positive. Never have an impulsive nature ki if you're putting a negative sign here, so the root will be negative. No, you have to analyze. So this root is also coming to be positive. So this is also physically acceptable answer. It means at this time also the motorcycle would be meeting the police car. Now let's see what is the significance of two answer. What is the physical significance? Because everything has a significance. Surely you can say this is a lesser time and this is a higher time, correct? T2 is less than T1 here, if you're taking the two roots, because this is being subtracted. So what it means suppose, because kinematics equation don't know whether the police car is catching the pickpocket or not. So see, this event is T0, this is car, this is D, and this is the motorcyclist starting with a velocity of 0 and going with an acceleration of A, correct? Now what will happen after some time? Suppose the car is not going to catch the motorcyclist. So at point A, they would be side by side. This is the car, this is the motorcyclist. This is the first time. Though this is another thing, here the policeman will catch the motorcyclist. He won't leave him. But kinematics don't know. Kinematics will give you the time when they will have the same position. Okay, kinematics is not concerned whether the policeman is going to catch the motorcyclist or not. So kinematics is telling you there will be two instants. There will be two instants when both motorcyclist and the police car will be having the same position. So this is the first time, that is the lower time, lower value of t. Of course, in our solution it will be T2 because we have taken T2 as the lower value. Now what will happen? Once again, they will be side by side. This is the second time. Okay? And this is the higher value of t, which we have taken as T1. So basically, had the policeman been not catching the motorcyclist, then they would be side by side at two instants of time. And if you want to visualize the scenario graphically, what is happening here? See, this is the time axis and this is the position. Policeman is starting from origin, motorcyclist is starting from a distance d. Okay, policeman is traveling with a constant velocity. So if you are making the graph of the policeman, it will be a straight line, correct? With a positive velocity. So this would be the graph of the policeman. Can you see? A straight line graph. And motorcyclist is starting with 0 velocity and with uniform acceleration, so his graph would be parabolic. So the graph of the motorcyclist would be parabolic like this. So see, these two graphs are meeting at two places. Can you see? They are meeting at two times. One is there and one is there. So at two times in future, they will have the same position. See, what will happen? First, the police car would overtake the motorcyclist. Can you see? At this time, car is overtaking the motorcyclist and the motorcyclist will lag behind. Motorcyclist is lagging behind. See the pink line. This is the motorcyclist. Then what will happen, since the motorcyclist is having accelerated motion, so his speed is continuously increasing. So one more instant will come when the motorcyclist is overtaking the car. Okay, this motorcyclist is overtaking the car. And now the car will never be able to overtake the motorcyclist because now this graph will go straight and this will go upward, something like this. So now it won't intersect anymore. So this is the physical significance why we are getting two values of t. What is the significance of two values of t? Because they will be side by side two times on the road. Okay, once the car will overtake the motorcyclist, this point, and after some time the motorcyclist will again take the car because motorcyclist is having an accelerated motion. Got it?
Let us see in this animation that how bus and a man are meeting twice at two instants of time.
That's another thing. the policeman will not give the opportunity to the pickpocket to have the second meeting, correct? He will catch him at this lower time only. So if the problem says ki at what time he will be caught, if the problem demands for the time at which the pickpocket will be caught, then this will be the answer. Okay, because the policeman is not going to leave him at the very first time when he will be side by side. So the second time will not be realized in future. But had the policeman been not catching that motorcyclist, then they would be meeting again at a second time, at this higher time. Got it? So both the time are coming positive. So positive time is not making any difference here. So the only thing we have to check is that the root must be real, and for this we are getting only this condition: v is greater than equal to root of 2ad. And this we have to prove, correct? So see, the proving came that the motorcyclist or pickpocket will be caught if v is greater than or equal to root of 2ad. Got it?